Hello and welcome. I'm going to show how to use the Simplex method to optimize, which means maximize or minimize an objective function. In order to solve this problem, first of all we need to rearrange the equations. As we can see, z minus 40x1 minus 88x2 equals 0. And in the same way, we're going to rearrange the constraints. So we have 2x1 plus 8x2 plus x3. x3 is a new variable called slack variable. And we use this slack variable in order to convert the inequality here to equality. Similarly, we rearranged this constraint. After rearranging the equations, the objective function and the constraints, we write them as a linear system of equations. And now we're going to write these three equations in the matrix form. This column represents the coefficients of z, and this column represents the coefficients of x1. This column represents x2, and so on. So in the first equation we have 1, the coefficient of z, so we write 1 here. We have minus 40 in x1, so we write minus 40. Minus 88 in x2, minus 88. And we don't have x3 or x4, so we write 0 and 0. And the constant here is 0, so we write 0 in the B column, which represents the constants, 0, 60, and 60. Now let's go to the second equation. We have 2, the coefficient of x1, so we write 2 here. We don't have z, so we write 0. And we have 8, the coefficient of x2, so we write 8. x3, we have 1, so we write 1. And we don't have x4, so we write 0. And in the same way, we write the coefficients of the third equation. Now, in order to maximize the function, we need to remove all negative numbers in the first row. First of all, we are going to select the first column that contains a negative number from the left. So this is the first column that contains the negative number starting from the left, minus 40. So we're going to select this column as pivot column. Now we need to select a row that's going to decide what is the pivot element. We're going to divide each of these two elements by the corresponding number in the pivot column. So we're going to divide this 60 by 2, and we get 30. And 60 divided by 5, and we get 12. So we're going to select the row that gives the minimum result, which is 60 divided by 5. Now we have the intersection of the column and the row is this element, which is called the pivot element. In order to simplify the solution, we are going to divide all elements in the row by 5. And this is the result. We get 1 here, and we divide all elements by 5, and we get these numbers now. Now, we need to make the elements above the pivot, which is this number and this number, equal 0. In order to make this element equal 0, we need to add 40 to this element. And in order to add 40, we need to relate this 40 to the pivot element. So we're going to say minus 40 plus 40 multiplied by this element. So minus 40 plus 40 equals 0. And we need to do this operation to all elements in the row. Therefore, row 1 plus row 3 multiplied by 40. So the first answer that we get is this element is 0, and we do the same to all elements. For example, minus 88 plus row 3 multiplied by 40 plus 0.4 multiplied by 40, and we get the new result here, minus 72. And we do the same to all elements, and this is what we get. We're going to do the same to row 2. And in order to make this element equal 0, row 2 minus row 3 multiplied by 2. Row 3 multiplied by 2. So we get this 0, and we do the same to all elements in the row, and this is the new row. Now we have this equals 1, and these two equals 0. Now I've just rewritten the same matrix here. Notice that the variables that have all elements equal 0 except 1, like x1 and x3, it has all zeros except 1. These variables now are called basic variables, while x2 and x4 are called non-basic variables. Those non-basic variables, x2 and x4, will be given the value of 0. Now we need to find the values of z, x1, and x3. I'm going to start with the third equation, or row, in order to find the value of x1. So we have 0 multiplied by z plus 1 multiplied by x1 plus 0.4 multiplied by x2 plus 0 multiplied by x3 plus 0.2 multiplied by x4 is equal to 12. And since we have x2 and x4 equal 0, we substitute x2 with 0 and x4 with 0. So we can see this term is 0, this term is 0, this term is 0, and this term is 0. So we have 1x1 equals to 12, or x1 equals 12. Now we are going to do the same with equation 2, or row 2. And here we have 0 multiplied by z, 0 multiplied by x1, and 7.2 multiplied by x2, and 1 multiplied by x3, and minus 0.4 multiplied by x4 equals 36. Now we have x1 is 12, x2 0, we don't have x3, we have x4 also 0. And by solving we get x3 equals 36. Now we're going to apply the same to the first row, and we get this answer, z equals 480. This is still not the optimum result because we have another negative number in the first row. So we're going to apply the same procedure in order to eliminate this negative number. Because in order to get the optimum result, we need to eliminate all negative numbers in the first row. Similarly, we're going to choose the column that contains the negative number starting from the left. And we have only one negative number in the first row, so this is going to be our column. Now to choose the row, we're going to divide 36 by 7.2 and 12 divided by 0.4, and the minimum result will be chosen as the row, which is this row, because 36 divided by 7.2 is less than 12 divided by 0.4. And similarly, we are going to divide this row by 7.2. And in the same way, we need to make this element equal 0 and this element equal 0 and apply all changes to all elements in the rows. So this is the first row, and this is the third row. And since we have these two non-basic variables, x3 and x4, so we write their values equal 0. And x1 equals 10, and x2 equals 5. We do this just as we did in the previous case. Now this value of z is the optimum value because we don't have any more negative numbers in the first row. This is another example where we are going to minimize the objective function. So we start by rearranging the equations and the constraints, adding the slack variables in order to convert the inequalities to equalities, and we write the three equations. Then we write the coefficients of the three equations in the matrix form. Now the difference in the minimization process is that we are going to eliminate all positive numbers in the first row. So in the maximize problem, we eliminated all negative numbers in the first row. Now in the minimize, we are going to eliminate all positive numbers in the first row. And we start by selecting the first column that contains a positive number, which is this column. We have only this column. And again, we are going to divide 5 by 10 and 10 by 5. And 5 divided by 10 is the minimum. Therefore, we select this row. Now we have this pivot element, and we are going to do the same process. So we will divide it by 10, and we divide all elements by 10. Then we are going to make this element equals 0, and apply the changes to all elements in the row. And similarly, we are going to make this element equal 0. Now we have this variable x2 and x4 as the basic variables, while x1 and x3 are the non-basic variables that equal 0. So x1 is 0, x2 is 0.5. We obtain this in the same way as we did previously, and f equals minus 10. Notice that this is the optimum result because we don't have any other positive numbers in the first row starting from x1. Thank you very much.